Welcome to Sairam Tribble YouTube channel. Let us discuss Module 4 Unsymmetrical Fault. Right. Before getting into the topic, we must know what is the meaning of fault. What are the causes for creating the fault? How the fault is created, right? So, fault is either it may be double line to ground. If suppose transmission line wire broken, or if suppose a transmission line wire two lines touch each other. The causes are like if suppose the birds touches both the wires. If suppose one wire is falling into the ground and another one is in the transmission line. So those are faults are called as a fault in the power system. So here there is an unsymmetrical fault. First we'll see what is a symmetrical fault. Symmetrical fault is only like two faults will be there. One is uh, triple L fault and then triple LG fault. So here to here, right? So three line fault. If suppose anything occurs in the three lines, that is triple L fault, three phase fault. And if neutral will be there, three phase to one neutral, will get triple LG fault. Three phase fault. So the most dangerous fault is three phase fault. Symmetrical fault, because see symmetrical waveforms, right? Like this. So definitely that's a more dangerous fault. So it should not be reaches 3 to 5 cycle. If suppose it reaches 3 to 5 cycle, the whole system will damage, and the some major components, valuable components will damage and will burn out. So symmetrical fault 3 to 5 cycles, and with respect to time, in the sense the number of cycles per second, right? That is the frequency. So time period is 1 by frequency. So it should be less than 3 to 5 cycle. Okay. And we have a unsymmetrical faults, right? Unsymmetrical fault in the sense like LG fault line to ground, LL fault line to line fault, and then LLG fault. So those are the faults we can expect. Even though in the unsymmetrical part, a series fault will be there, and then shunt fault will be there. Shunt faults are like LG, LLG, triple L fault, double LG fault. But series fault is like open conductor fault, and then conductor like one to one conductor open. Those are those faults is called as a series faults we can expect, right? Mm. So in the previous class we discussed the symmetrical components, symmetrical faults, and then symmetrical values, and in terms of phase components, positive sequence, negative sequence, zero sequence. And here also same thing, unsymmetrical fault also will get positive sequence, zero sequence, negative sequence. We have to draw the reactance diagram. They used to give one single line diagram. We have to draw one single line diagram. After that, reactance diagram. After that, we have to determine a fault. They'll mention fault location, so we need to calculate, right? So let's move on to the topic. See here, symmetrical fault, 3L fault, only 5%, but very dangerous. This is a symmetrical fault. Keep it in your mind. Definitely one question they may ask in your competitive examination, which fault is more dangerous? A three-phase fault, that too 5% only. Equipment will damage, or the person will get damaged and more shock. So that's a, like rarely we'll get it this fault. Okay, symmetrical fault. And next there is a double line to ground faults, only 10% of occurrence. Okay, this is also somewhat dangerous in the unsymmetrical fault. These all are the unsymmetrical fault. Okay, and this one is symmetrical fault. And double line to line fault. So for example, if suppose two wires touch each other, and if suppose the board touches both the wires, so that we can call it as a double L fault. L to L fault. See, symmetrical fault, three lanes would be there, and for double line to ground, two lines, one ground will be there, neutral will be there. And another double line to line fault, only two lines will be there. Okay, LL. And single line to ground fault, so one line will be there, one ground will be there. Like a fault in the ground. So this one is fault in the two lines, this one is fault in the two lines with the ground, this one is fault in the three lines, right? So these are the faults will be there in the power system power system analysis subject. So single line to ground fault, so it's a frequent fault. uh, so it's normally this fault we can expect 70% of fault is single into ground fault. So if suppose changing the wire, changing the phases, changing the transmission lines, power supply from one area to another area, that time we can expect this one is it's not a dangerous, and it's also like a fault, right? Okay. Next, fault calculation synchronous generator. This is a synchronous generator, everybody knows, right? So this one is a stator conductor, and this one is a induced voltage in the stator conductor. See here, there is a rotating magnetic field is present. When a conductor cuts this rotating magnetic field, what happens? Induces EMF in the all the conductors. So synchronous generator, particularly we are using in power plant for more power generation, right? So this conductor rotation, field rotation, directly proportional to induced EMF in the stator conductor. So directly proportional to induced voltage and output voltage is called as a synchronous generator. It rotates at synchronous speed. See here, why particularly they have taken synchronous generator. Synchronous generator is in is we are using in power stations. So that's what whatever generating station to power supply from the power plant to home. So that's AC. So it will be produces AC power supply to the output side. So that's why it says a called as a synchronous generator, rotates at synchronous speed, and is equal to 120 F by P, right? And also we can call it as alternator. So alternator we can find in the hybrid cars also. So uh, let's go on to the topic in the next video. So let's see. I mean, please watch all the videos for better understanding, and series videos you should watch, and so that is helpful for your UT examination, right?